Good morning. I'm Davi Rodrigues. I'm a professor at the Federal University of Espírito Santo, and I'm going to talk about post-Newtonian gamma light parameters and the sleep. This work was done in collaboration with Junior Toniato, who is currently a professor at UFOP. The gamma parameter within PPN formalism, gamma appears a constant and in a context of a post-Newtonian expansion. We only need expansion up to second order on the velocity field. This implies that you can talk about the Newtonian limit, which is here. U here is the Newtonian potential, actually the negative of the Newtonian potential. I'm using G equal to C equal to 1. And gamma appears here in the spatial parts. You see here gamma. Gamma here enters as a constant. This leap appears in a cosmological context. That's why here I wrote the line elements of cosmological scalar perturbations. You can find here the scale factor, the time part of the scalar perturbation, and here the spatial part. But the spatial part I wrote as eta psi, where eta is defined by phi over psi. So this eta here is the slip. If you want to assume that A is essentially a constant inside the system, for instance, inside a galaxy, you can always assume that A is a constant. If it's all assumed that there is a valid Newtonian limit, which implies that psi is equal to U, and also if eta is a constant, then it's correct to say that the slip is equal to gamma. But however, in general, these quantities are different quantities, and also they probe different physics. The physical meaning of gamma is that it measures both light band and the Shapiro time delay. That's how it appears in the PPN formula in the standard way. It has a connection with the observation. It has a connection with these two physical phenomena. And it's bound in the solar system. Is stated as here. You can see that it's very close to 1, where 1 corresponds to GR. A simple and useful extension of gamma we propose in our work, which we denote by this gamma sigma. So first we consider this line element here, in which we use here an arbitrary alpha E and an arbitrary function gamma E. So these two functions here, alpha and gamma, are arbitrary, and they are only multiplied by U, the Newtonian potential, by convenience. So they can even depend on time, this alpha and gamma. In general, gamma E is different from gamma, which is different from eta. In this work of ours, in part inspired by this work by Bell and Gaillier, we propose the use of gamma defined in this way, which is just the sum of alpha and gamma subtracted by 1. And we show explicitly that if gamma sigma is a constant, then parameterize both the Shapiro time delay and the band of light. Also, it's important to state that we have shown that there are several models that indeed gamma sigma is a constant, hence it's a useful parameterization. In particular, I'm talking here about Rondesk application. I'll go straight to Rondesk without talking about Brunstick, which as we do in our paper. So in Rondesk, we show that whenever it's possible to locally approximate the Rondesk potential by their analytical expressions, one can say that gamma sigma is a constant. Here's the general expression. This kappa and G400 are constants. So gamma sigma will be a constant in Rondesk. And moreover, if there is a valid Newtonian limit, then gamma sigma becomes equal to gamma. And here are the expressions. These two expressions here, when the Newtonian limit is valid, appear before in these two works here. And we agree exactly their results. However, these two works argue that when there is no valid Newtonian limit, which is a possibility in a distant galaxy, perhaps there is no valid Newtonian limit in a distant galaxy, they argue that one should use the slip in place of gamma. As we say here, no, we don't agree with that. The most natural parameterization talking about physics would be gamma sigma, which is this one here. And the gamma sigma, since gamma sigma is a constant, one can talk about light deflection as written here in this expression. As you can see, this is exactly the same expression that appears in PPN, but with gamma replaced by gamma sigma, which is possible since gamma sigma is a constant in this context. So let's go to the conclusions. So the point that care should be taken on the meaning of gamma PPN, and the true gamma that appears in PPN formalism cannot be approximated by the slip. The error can be either negligible, we cite in our work some examples in which the error is indeed negligible, or can be arbitrarily large. If gamma sigma is a constant, then this quantity parameterizes the same physical phenomenon of gamma, even in the absence of Newtonian limit. This is very important. In general, it's important to stress also that gamma is different from the sleep, which is different from gamma E, which is also different from gamma sigma. In conclusion, and also in our work, we pointed out that in principle, it's possible to test that gamma sigma is a constant. So we can probe if gamma sigma is a constant or is not in a distant galaxy, but it is not easy to do. In principle, this can be done by looking for double asteroid ring systems. This is as done as this figure here is an example. So I'll stop here. Thanks for your attention.